Hi, welcome back. In this video, we're going to talk about isosceles and equilateral triangles. These two are some of the most popular triangles we're going to be talking about in geometry. So we're going to identify some of the properties that make them unique, try a few practice problems, and then call it a day. If you have not liked liked my video just yet, go ahead and click the like button. Subscribe if you haven't done so already. Let's begin. Okay, so let's define these two triangles. We spoke about this in one of the first videos, the different types of triangles. An isosceles triangle is a triangle that has two congruent sides. These two sides, we call them the legs of a triangle. Across from these legs, let me copy this here. Across from these legs, we have these opposite angles right here, angle A and angle C. Now, if you think about it a little bit, angle C is opening up to this side. If I focus purely on the legs, right? If I focus on that angle alone, angle C, the bigger the angle, then the bigger this segment's going to be. And if I shorten this angle, if I make it smaller, angle or line AB should also shrink. So the opposite side of the angle should be dependent on the size of the angle. Okay, so this angle will determine how long this side is, and same with angle A. Angle A will determine how long this side is. So if the two sides open up to the same amount, that means that the two angles in the bottom are also going to be congruent. So we call these base angles. Here and here. So a isosceles triangle has two congruent sides and two congruent angles. Equilateral triangles will have all equal sides. Now, if the sides are equal, we can then assume that the angles are also going to be equal to each other because they are opposite sides, right? So 3 congruent sides, 3 congruent legs for equilateral. This can also be known sometimes as equiangular. It's an equiangular triangle because all the angles are equal, or all the sides are equal, the laterals, the sides. So here's an example. I can tell from this picture that this is an isosceles triangle because we have two angles that are the same. Now these two angles are sitting right across and opposite to the sides that are congruent. So I can assume that right across from it, this side will be congruent to this other side. Okay? So the angle will always be opposite to the sides that are congruent. This side should be congruent to this side. And that's how you will set up your equation. You have 2z minus 15 equals 9. So then to solve for z, we move the 15 over. We do plus 15 on both sides. 2z equals 9 plus 15 is 24. Divide both sides by 2, and you're left with z equals 12. The way to set this up is identifying which two sides were congruent, and that's dependent on the angles provided. Let's try this other one. I can tell this one is an equilateral triangle because all three angles are the same. That means that all three sides are the same. So, since I'm given these two sides, I know that those two sides are going to be congruent to each other. Technically, all three are congruent to each other, but we only have 2 measurements, and that's what we're going to solve for. So my equation becomes 2x minus 6 equals 12. So to solve for x, we move the 6 over. 2x equals 18. Divide both sides by 2, leaving us with x equals 9. All right, last example. Here, this one's going to be a little bit, that's going to require a little bit more thinking. But I wanted to isolate the triangles. I'm going to focus on the triangle on top first. This triangle up here. If I look at that, I notice that I have 2 congruent sides. So the 2 congruent angles will be opposite of those sides. The angle across and the angle across are both going to be congruent. So I can say that this angle also equals 65. Now, if I know that they're both 65, and all of these 3 angles in this triangle add up to 180, 65 plus 65 is going to equal to 130. Now, since they all add up to 180, I can subtract 130, and I'm left with 50 degrees. So this angle right here equals 50 degrees. Now, on the other side of this angle, or this triangle, I have vertical angles. I have this blue triangle. These 2 angles are vertical, which means that they're going to be congruent to each other. So if that top angle is 50, right across from it, we have 50 degrees as well. Now, I now focus purely on the blue triangle, and I noted that these 2 sides are congruent. So right across from them, I have angle 50, and right across from this other angle, this will also be 50 degrees. These 2 will be the same. These are the base angles. Remember, they're always across from the congruent sides. So if this side is 50, the question now is what's left over, right? All 3 angles have to add up to 180. 50 plus 50 is 100. And if the whole thing is 180, I can subtract that, and I'm left with 80 degrees. Therefore, x equals 80 degrees. It comes down to, do you know how to read the tick marks and identify which base angles are the same, and then that all the angles add up to 180. And you can find one value. You can start with the 65 and find your way all the way to x using these 2 properties. The interior angle sum theorem, where all the angles add up to 180, and the properties of isosceles triangles, where the base angles are congruent and they're opposite to the side legs that are congruent. If this video was helpful, please let me know by clicking the like button and subscribe if you haven't already. And as always, we'll calculate later.